we've already set up and practiced with a couple of mass-to-mass calculations. What we want to do is move on now and see how this is going to apply to some very practical things that you would do in chemistry. Okay?
Mr. T, I just want to thank you for putting these videos up. It really helped me.
Okay. Well, I'm glad.
I post them on Facebook. No, I just get my video up.
Okay, thank you. So what we're going to start now is putting it into some practical terms. The first thing we want to determine is what's called a limiting reactant. We're going to determine a limiting reactant. Now this problem is going to get even more complex. I'm going to build on this one problem. After we determine the limiting reactant, we're going to determine what's called a theoretical yield. After we determine the theoretical yield, then we're going to determine whether what our actual yield is. I want to give you an actual yield. We're going to determine what's called the percentage yield. Okay, but for right now, we're going to start with just this step. Okay, if you're given the amount of two reactants, and you're asked to find a product, here I'm asking you to go ahead and find the limiting reactant. But if you're just trying to find the amount of product, you first have to find the limiting reactant. So this applies to a real-life lab sort of situations, or even a manufacturing problem. If I have a certain amount of sugar and a certain amount of flour and a certain amount of butter, and I want to make cookies, okay?
Yummy, yummy. Cookies.
I need to know what ratio of these things I have to figure out what amount of cookies I can make. Because I got to match the ratio that's in the recipe. Okay? If I want to make the most possible number of cookies, then I have to figure out what is the material, the flour, the sugar, the butter, which one's going to run out first. And that's the limiting reactant. So what we're doing here is kind of the same thing. We're determining the limiting reactant. What is going to run out first when we run this reaction? Now this is a mass-to-mass problem. The same stuff we were doing last week. All we do is start with one reactant. It doesn't really matter which one. I can start with the 5 grams of iron 3 sulfate or the 5 grams of calcium nitrate. Doesn't matter.
Start with the iron sulfate.
All right, we'll start with the iron sulfate. Okay? So we're going to put that 5 grams of iron 3 sulfate. So you have to be able to write formulas. Going back to what? Was that unit 3 we started in learning to write formulas? Okay. Iron 3 has a 3 plus charge. Sulfate has a 2 negative charge.
Yep.
How many irons do I need? I need how many irons? 2 of them. Okay. Fe, and I need 2 of those. How many sulfates do I need? 3 of those. Okay. So we're going to start with that. And if we're going to do a mass-to-mass problem, then we need to put this starting amount over 1. Now, I first got to convert this to moles. You can't get anywhere in stoichiometry without going through moleville. Okay? Got to go through moleville.
Yep.
All right? So we have to calculate the molar mass of this stuff. Okay? And you can do it on your paper however you like. I like to kind of go down to the bottom of the paper and do it down there. All right? I'm going to do it down here, okay? So here's iron and sulfur and oxygen. And look on your periodic table and you'll see that iron has a mass of 55.845. And sulfur, everybody have out their test references? Are you following along with me?
Right here.
32.065 is sulfur. And oxygen is 15.9994. All right, looking back at the formula, I have 2 irons, so I'm going to have to multiply this mass by 2. This 3 outside the parentheses means that I have 3 sulfate polyatomic ions. And each sulfate has 1 sulfur, so I have to have a total of 3 sulfurs. Okay? And since each sulfate has 4 oxygens, I have 3 sulfates. That means I have a total of 12 oxygens. Now I'm ready to start doing some math. Need your trusty calculator. And your daddy trusty calculator. That's right. Okay.
That's like Blue's Clues, like a handy dandy notebook.
55.845 times 2. And I've got 111.69. Now, hearkening back to Unit 1, I'm trying to write this so I can keep all the digits lined up neatly for rounding purposes. Okay? So then that's right, significant digits, 0.065 times 3. And they get 96.195. And then this is 15.9994 times 12, and I get 191.9928. What, 15? Okay, well, if you got 993, then your calculator set up to round off to 3 digits, and you can take off that. You change that so it doesn't round off at all. 99 what?
Yeah.
You put in 15.9994.
That's a 4.
I'm sorry.
It's alright.
Well, I asked if you had your periodic table. You read your own periodic table, you can see it's a 4.
I trust you.
Even if you can't, I know, but if you can't read my writing, and trust me, I have that problem on tests a lot.
Yeah.
Okay? All right, now let's be careful about something. Let's look back up here. I multiplied this number times 2, and I only got 2 digits past the decimal when I started with 3 past the decimal.
How did that happen?
How did that happen? What happens when you multiply 5 by 2?
You get 0.
So that you need to know. You need to know. This is your responsibility to know there should be a 0 there. Okay? Your calculator is not going to tell you that. Okay? You need to know that. Because in chemistry and in all the physical sciences in particular, all sciences really, but the physical sciences are more, it becomes more important. You want to make sure you keep up with the significant digits. Now, if you're going to round this off properly, you need to know that that has 3 digits past the decimal, which will leave us then when we're done with only 1 empty slot out here on the right.
Yeah.
Okay? So now we're ready to add all that up. 111. No, I got 4. I have 4 digits past the decimal for this oxygen.
That's an 8 on the end, not a cold. That's an 8. Mr. Tedder.
Yes.
What is that?
What?
I think you need to tell the people what time that's an 8.
That is an 8.
I got him, Mr. Tedder. I'll tell him what your handwriting is. Don't worry. You just focus on See how that goes down.
Okay, and so I get a total of 219. See, I plugged everything in right. The light's kind of funny up here.
I got $3.99.
Yeah, I punched the button wrong. Hold on.
Oh my gosh.
I know.
Killing me small.
Okay, yeah. Yeah, I need to get two lamps that point in from the sides and not one that points in from the top.
You gotta play in the rain, Bill.
So this is $3.99. .8778.
Oh, yep.
Okay, and we're going to round off that last digit. And we're going to use an arrow to show we've rounded the answer. And so I get 399.878. Now this will be grams of iron 3 sulfate equals 1 mole of iron 3 sulfate. Okay? So we have an equality statement down here now, and we're ready to put that into the formula of the equation up here. Remember, what I want to do here is to match the side of the equality statement, or match the units and species on the side of the equality statement that matches the units and species in the starting amount. Stu, you had a question?
Is there no subscript of 3 after the sulfate?
Yeah, there is.
No, I didn't know if you would.
No, I was going a little fast, trying to think ahead. Okay, so we want to put 399.878 grams of iron 3 sulfate on the bottom because it matches the units and species of my starting amount over here. So that goes on the bottom. And put the other side of the equality statement on the top. 1 mole of iron 3 sulfate. Okay, and we're going to cancel as we go. Okay, all right, so we've successfully navigated our way to moles. And since we've got to go from moles of one thing to moles of something else up here in the problem, moles of iron 3 sulfate to moles of calcium nitrate, can't go directly between grams. You got to go through Moleville.
Yep.
We need a balanced equation to do that.
E-force.
Well, I don't have a balanced equation yet, so I better do that.
Yeah.
So we got iron 3 sulfate ooh, I didn't say those were aqueous, did I? Ooh, that's bad.
No.
Let's add aqueous up here to this. You wouldn't have known. And we're going to make this aqueous here too. Okay, those need to be aqueous. Okay. And we've got calcium nitrate, and so that's calcium is Ca as a 2+ charge. How would we know that if you didn't know that? The periodic table of oxidation numbers, you can look that up. Calcium only has one oxidation number. Nitrate has a 1 negative charge. If you didn't know that, where would you look it up? Common ions list. So how many of each of these do I need? What? 2 nitrates. So I put a parentheses around it, put a 2 outside, and this is aqueous. Okay? So